Hello and welcome to Diplomatic Derivatives. In this episode of Diplomatic Derivatives, Pure Mathematics Group Theory, we are working on Permutation and Symmetric Groups Part 3. We have already uploaded Part 1 and Part 2 of Permutation and Symmetric Group, where we have explained in detail what is a permutation, the different types of permutations, and different other concepts, including the product of permutation. So those are important topics. Make sure you check them out before moving on. So in today's video, we're going to talk about transposition, inversion and signature, and even an odd permutation. So without further ado, let's move forward. Now, first of all, we understand what is a transposition. A cycle of length 2 is called a transposition. Now, it's not an alien concept. It's very easy. For example, we just explain it with the help of an example. So we have sigma this is one permutation which is named as sigma. Now, from this permutation, what do we see? We have to make cycles. Okay, so how do you make cycles? We have explained this in the previous video, so check that out. The link is in the description box as well as in the I button above. So how do you make those cycles? Just a quick review. We start with 1, so 1 goes to 4, you write 1 4, 4 goes to 5, you write 5, then 5 goes to 1, so the cycle stops here. That is one cycle. So it's 1 4 5. Then you go to the next number 2. So 2 goes to 6, you write 2 6. Then 6 goes to 3, you write 3. And then 3 goes to 2, so the cycle continues. Therefore, that's how you write the next cycle. Next, we have all these numbers are done. So now you come to 7. 7 goes to 8, and 8 goes to 7. So that's 7, 8. So what did we get? We get 3 cycles. Okay. Now, what is the order of permutation? Also explained in the previous video. How do you get that? You take the LCM of these 3 cycles. So the order over here is 3. That is, the length of the cycle is 3. Length of the cycle is equal to the order of the cycle. We get 3. Then for this one is also 3, and this is 2. So take the LCM, you get 6. So this is the order of this permutation, which is 6. All right. And how do you make transpositions now? Which is this thing that we're basically talking about, transposition. So you use these cycles to make the transposition. You have first cycle, which is 1 4 5. Now, what does the transposition definition say? That it's a cycle of length 2. So from this one single cycle, you will make transpositions. So you have to make sure that the length of cycle is 2, means the first cycle is going to be 1 4, then 1 5. So this is what you get from 1 4 5, these 2 transpositions. Then from the next one, it will become 2 6 and 2 3. Then 7 8 is already 2 cycles, so it is written as it is. So you converted this into transpositions of length 2 2 2, right? So these are the transpositions of this permutation. The main thing is the length of the cycle is 2 in each of these. All right. Now, order of every transposition is 2, because length and order are same, right? That is, every transposition is self-inverse. Every permutation is a product of transposition. So here we can see that clearly that this permutation is a product of transpositions. All right. So next concept is inversion. If sigma be a permutation, then the pair ij, 0 less than I less than j less than or equal to n, is an inversion for sigma if sigma I greater than sigma j. So the concept here is that we have 2 elements, right, which are part of this permutation. We take one is I and one is j. Sigma I and sigma j, what are these? These are the images. So image of I is sigma I and image of j is sigma j, right? Now I is less than j. This is what you keep in mind. I is less than j, but the image of I is greater than the image of j. And then that pair of I and j is then called an inversion. This is the condition. So how do you do this? How do you perform this? Now you say, let's suppose we have sigma is equal to 1 2 2 4 3 1 4 3 5 6 and 6 5. All right, this is one permutation. Now, first we start with 1. We say, let's suppose 1 and 2 are the 2 elements I and j. Okay. Now, what is the image of I? That is sigma I, and then sigma j, the image of 2. Okay, since 1 is I and 2 is j. So 1 is less than 2 according to this. and the image of I is less than 2 again, which is not true, because the image of I has to be greater than the image of j. So this cannot be an inversion. Next, you check for 1 with 3. 1 is less than 3, according to this, correct. Then according to this, the image of 1 should be greater than the image of 3. Is that true here? The image of 1 is 2 and the image of 3 is 1. So the image of 1 is greater than the image of 3. The condition is true. Therefore, the pair ij, which is 1 and 3, is an inversion. This is what it means. Okay. So next you check for, so this is what's written here. 1 is less than 3, but f of 1, which is that is the image of 1, is greater than the image of 3, which is equal to 2 is greater than 1. Therefore, the pair 1 and 3 is an inversion. Alright. Similarly, you check for 1 and 4. 1 is less than 4, but the image of 1 is also less than the image of 4. Therefore, 1 and 4 cannot be inversions. 1 and 5, again same case. 1 and 6, again same case. Next, you check for 2. 2 with 3. Because 2 with 1 you have already checked, right? And obviously you cannot go back, because this is the main first condition, that I is less than j. So you keep going forward, okay? 2 with 3. 2 is less than 3, but the image of 2 is greater than the image of 3. So the condition is true. Therefore, 2 and 3 is an inversion. So pair 2 and 3 is also an inversion. Then 2 with 4, again same thing, also an inversion. 2 with 5, no, and 2 with 6 also no. Rest you keep on checking. Another one which you get is 5 and 6. So 5 is less than 6, but the image of 5 is greater than the image of 6. Therefore, 5 and 6 is also an inversion. Okay. So from this permutation we got total of 4 inversions. So in the examination, for example, a question comes, find the inversion of the following permutation. This is how you perform that question. Okay. So you keep checking for each element, you keep going forward, not the backwards, because the first condition is I is less than j. Okay, so this is how you perform this inversions, and this permutation has 4 inversions, 4 pairs of inversions. All right, and the number of inversions for a permutation is known as signature. Okay, so the previous on the previous slide, the example that we used, it had 4 pairs of inversions, right? Therefore, the signature of that permutation is 4. All right. Then we have even and odd permutation. A permutation is called even or odd if the total number of transposition is even or odd. So we have an example over here with which you will be able to understand what is an even permutation and what is an odd permutation. In this example, we have P is equal to 1, 2, 3, 4, 5. A cycle is given to you, and it is having the length as 5, because there are 5 elements, right? So the order or the length of this permutation of the cycle is 5. But what are the transpositions? 1, 2, 1, 3, 1, 4, and 1, 5. So how many transpositions did you get? You got 4 transpositions. And a permutation being even and odd is linked with the transpositions. All right. So if the transpositions are even, then the permutation is also even. All right, here we see that there are 4 transpositions, therefore it's an even permutation, because the number of transposition is 4. Now, one thing that you have to keep in mind is this, that a cycle of length n is called even or odd if n is odd or even. So we take the same example and try to understand what the statement says. We just said that the matter of permutation being even or odd is linked with the transpositions, right? But when you look at a cycle, the cycle itself is having odd number of elements, right? The length is odd. So if the length is odd, then the order of the cycle is odd, or the length of the cycle is odd. That means that the permutation is even. So with the length, it's the opposite thing. With the transposition, it's the same thing. This is what it means. That if the cycle is odd, then the permutation is even. If the transposition is odd, then the permutation will be odd. Alright, and vice versa. So this is what you have to keep in mind. Identity permutation is an even permutation by default. Okay, every transposition, how do you say that? Because identity is just one element, right? Identity does not have any other element, and that means that cycle is odd, and for odd cycle it's an even permutation. This is what the statement just said. Okay, for an even cycle it's an odd permutation, and for an odd cycle it's an even permutation. Every transposition is an odd permutation. What does this mean? Because every transposition, what is the length of a transposition? A length of a transposition by definition is 2, right? So if the length is 2, which is even, the permutation is automatically odd. Okay, that is what that means. Now, product of even or odd permutation. Product of two even permutation is an even permutation. So if you're given two even permutations, the product is going to be an even permutation. For example, you have sigma 1, 2, 3 and p is equal to 3, 4, 5. The cycle is odd, therefore the permutation is even. Same goes over here. So when you find the product of sigma and p, which you will be able to perform if you have seen the previous video where we have explained the product of permutations, also the one before, so check that out. The link is in the description box below again. Now when you do that, the product thing, then you will get a permutation, right, which is also an even permutation. The cycle is odd, so it's an even permutation. Product of two odd permutation is again an even permutation. So if you have two odd permutations, the cycle will be even. All right, if you have two odd permutation, you will get an even permutation. Take two odd permutations, perform the function, and you will be able to understand it clearly. All right, product of even and odd permutation is odd permutation. This is the condition where you get an odd permutation as an outcome only when one cycle is even and another cycle is odd. So when you perform that, you will be getting an even, so you will be getting an odd permutation. All right, that's how you, and try to perform this with the help of an example. Use the same example given over here, try to solve it, and you will be able to understand it much clearly. If you still have doubts, type it down in the comment box below. I'll be able to help you as much as I can. All right, so that's all for this video. Thanks a lot for watching and being here till the end. I'll be continuing with this topic in part 4. 2 parts are remaining, so we will be doing that to clear all your concepts. So for the time being, make sure you like, share and subscribe to my channel. If you have any doubts, type it down in the comment box below. And that's all for today. Thank you. Bye bye.